Hi everyone, I am back with another free SQL Server tutorial, another free SQL Server demo. Today's topic is spilling into TempDB, more specifically sort spilling into TempDB. Now sorting in itself is not a good thing because such an operation like sorting or hashing requires a lot of resources from SQL Server's perspective. But there are reasons why you may want to sort. Now the problem with sorting is when you ask SQL Server to sort, it will take the data set that needs to be sorted, and it will try to do that in memory. But if there isn't enough memory for SQL Server will then spill that data to TempDB. Now sometimes what might also happen that there is a lot of memory available in SQL Server, yet SQL Server is spilling that data in TempDB. Now that's a very tricky situation because that might happen due to poor estimation. So what internally happens with the optimizer is when you ask SQL Server to sort, it estimates the amount of data that needs to be sorted. And then based on that data, when I say data, the data set in terms of number of rows, and then it estimates the total data size. Based on that, it will try to reserve memory. Now, let's say for some reason the estimation goes wrong, the amount of memory that it is going to reserve will be incorrect. And when actual execution of the query happens, the execution engine finds that, oh, we estimated only 200 MB, but now the data is like 2000 MB. And then things go bad and SQL Server will start spilling down to TempDB, even though there is a lot of physical memory available for SQL Server. So there are these couple of reasons why spilling happens. So let's look at a very quick demo to understand how spilling happens, the different levels, and then maybe a quick technique to fix that. All right, let's get started. We are using AdventureWorks 2016 for the purpose of demo. What I've done is declared two variables here, min quantity and max quantity. Look at the initial values for them, 0 and 2. Here is a very simple query, select start from transactions table, where the quantity column values are between min quantity and max quantity. And then we do order by quantity. So we are asking SQL Server to order by quantity. Now the values 0 and 2 are minimal so that we just get a minimal set of data. Transactions table is actually a huge table with about 30 million records. Let's first go and execute this and turn on the actual execution plan, or press Ctrl M. Let me just minimize this a bit. Let's go and execute and see what is the output like. So the data starts coming in. We have turned on actual execution plan. Let's wait for a few seconds. Okay, the execution is done. It took about 8 seconds to execute, and we have about 600,000 rows. Let's jump over to the execution plan, and what you will see, first few things that you will observe is, okay, we get a plan with sort. Of course, that was expected because we are sorting data by quantity. This also means that the data is not pre-sorted. So the first indication, okay, we are sorting. The query is parallelized, which means SQL Server is deploying multiple threads for this execution. And then another thing that I notice is SQL Server is leveraging an index. It is using a non-clustered index that has been created or that exists. Fine, all good. Now, I made two statements here. First thing, sort itself might not be good. And the worst thing that might happen that you are sorting and then the sort is spilling into TempDB. At least till now we are sorting, but sort is not spilling into TempDB. So we're all good. If you take the cursor over here, you will just see output list, order by, nothing alarming, so to say. Because you know that when sort starts spilling down into TempDB, execution plan will give you a warning, right? There will be a visual indicator that things are not going good. Now what I will do is I'll expand the scope. Instead of max quantity as 2, let's make it 20. Okay, let's go and execute this now. And actual execution plan is already turned on. So what we have done now is We didn't look into the estimates, which is estimated number of rows and actual number of rows. We will do that now, but all I'm trying to tell you here is by changing the value of max quantity, now we will get more records being returned by the optimizer. You know what I should do is just cancel this for the moment, because I want to actually show you the estimations, you know, when the quantity was 2. Maybe I missed that out. Okay, let's do this once more, no problem. So minimum quantity is 0, maximum quantity is 2. Let's go and look into the data size, estimations, and actual number of rows. And this, let's record that. Okay, so we know we have 625108 records being returned. If you look at the status bar there, which is about 600,000, jump over to the execution plan, and I'll take the cursor over this arrow. This arrow is a good indicator of where things are. So if you look at the estimated data size is about 171 MB. We are looking at actual number of rows as 625, and this is what SQL Server estimated number of rows, about 5 million or so. So this is the default estimation. Okay, and now what we will do is let's close this. So what you need to notice here is the actual number of rows is 625, which is way less than estimation. So SQL Server actually estimated quite a bit, and your actual number of rows is way lesser, which means the amount of memory the optimizer would have reserved for this entire data size of 171 MB would have been good. Okay, so that's the default assumption I'm making here. Now let's go and change this to 20. Let's go and execute this now. Now what will happen is, first things first, the estimation is going to remain same, and there is a reason for that. The reason is because we are using local variables. So that value of 5, 1, 2, whatever that 5 million is, and the data size set of 171 MB will remain same, because SQL Server does not know the value of local variables until runtime. So the default estimation will always remain same irrespective of the value that you assign to the local variables. And so whether it is 20 or 30 or 40 or 50, that default guesswork is going to be same, because that's hard coded. Now, if the default remains same, but the actual number of rows is going to increase way beyond what it was earlier. So earlier we had about 600,000 rows. Now this is really going to increase quite a bit. So it will be, of course, more than a few millions. That is what we are going to expect. The execution is still going on. Should not have taken that much time, but let's see, where do we stand now? It's past 1 minute and the execution is still going on. Okay, we are done. So it took about 1 minute 13 seconds. So now we have about 6.2 million rows being returned. So if you look at 6250787, let's jump over to the execution plan. And now the first thing that is going to catch your attention here is, apart from a lot of other things, is now there is a visual warning on the sort operator. Now you can see that the execution plan remains same. We still get a index hint. This is a parallel query with multiple threads. We are sorting, and then you have a sort warning. So let's take the cursor over sort here and jump over to the warning section. Operator used TempDB to spill data during execution with spill level 1 and 7 spilled threads. Sort wrote these many pages to and read these many pages from TempDB with granted memory, etc., and used memory, etc. Okay, a lot of information, which is good. I think this is from SQL Server 2016 onwards that SQL Server gives you more information about how many threads spilled, how many pages were written to and read, and some memory information. I remember from earlier versions of SQL Server, we just used to get information like, okay, spilling happened with the spill level, etc., but no information about threads or pages or memory. So of course, more information is given so that you could investigate and be more informed. Now, Sometimes memory information, the number of pages being read and written to, etc. And seven spilled threads is also understandable. I have 8 cores here, so there are 8 threads to the query. I'll just show that to you in a moment. Is kind of, these are static information, understandable. What about spill level? So you have spill level 1, and I'm sure you probably would have seen spill level 2 and more. So what does spill level really here mean? Now, spill level 1 or spill level 2, this number means that how many times SQL Server had to pass over the data to sort this entire data set in its entirety. Which means that in my example here that I'm showing to you, SQL Server had to only do 1 pass over the data. If this was spill level 2, which means SQL Server had to do 2 passes over the data. Which means what? Spill level 2 is worse than spill level 1. Obviously, spill level 1 is better than spill level 2. So the more levels you have, which means more passes over the data were done, which means the query is degrading in terms of performance. It's degrading even further. So if I really put this in perspective, sorting is bad. Okay, bad in other words, not good. I mean, you want to avoid sorting because it's an expensive operation and it affects query performance in simple words. So sorting is not good. Not good may be assumed as bad. Okay, so that is one. Second is sorting with spill level 1 versus spill level 2. So as you increase the number of levels, it goes even worse. Okay, so keep that in mind. Now let's close this and let's look at the estimations now. So now you can clearly see that actual number of rows returned are way more than estimations. But look at the estimations, the number of rows that were estimated and the data size. These numbers are same as what you saw earlier, and just want to reiterate that because we are using local variables here, SQL Server will always apply a default guesswork and these numbers are going to be same. But of course now SQL Server has this mismatch of actual versus estimated. So SQL Server needs more memory, probably it did not reserve enough, and then it's spilled down. Now mind you, this is not really a case of so-called poor estimation because you're using local variables. If these were hard-coded, maybe you may want to worry about updating these statistics, but statistics in this case are up to date. So this is just about not having enough memory available there, and of course because you're using local variable. Okay. Now let's talk about, so we have understood what sort spilling is and why it happens and what is good, what is bad. Now a couple of things. You may want to get rid of the spilling. That's your goal number 1. Goal number 2 could be you may want to get rid of sort altogether, right? So these are the 2 different goals that we might want to work with. Now, the first things first, when we look at the execution plan, I want to investigate which index it is using. Now, the easiest thing could be to just go ahead and create a covering index, etc. and pre-sort the data. That's definitely one of the things we might want to do. But before we jump into creating more indexes, we might want to look at existing indexes. So if I expand, okay, first let me see which index we are using. Okay, let's zoom in. So we are using IX product ID, that's the index. So let's expand AdventureWorks 2016, expand tables, and where do we go? We have transactions. There you go. So we have transactions, and under transactions table, you have this index IX product ID. This is being used. Right click. Let's go to properties and see what is the definition of the index here. So we have this is a composite index, multi-column index with 2 attributes here, product ID and transaction date. So these 2 attributes form the index key, and then you have included columns. So we have quantity and actual cost. Okay. If I go and expand the columns here, I can see that this table is a small table from the number, looking at the number of columns. So we have transaction ID, which is the primary key. Then we have product ID, transaction date, quantity, actual cost. So we precisely have 5 columns. Now looking at the number of columns in this table, and looking at this index. This index is an interesting index because it actually covers the entire table. It has all the attributes that the table has, in fact, because you have two key columns, product ID and transaction date. So two columns gets covered here. If you go and look into the included columns, you have quantity and actual cost, which makes it 4 columns, and transaction ID is the primary key. So the primary key, let me just look into primary key. Okay, this is my clustered index. Yes, so if you look at transactions, just let's go into properties of this transaction ID. This is the clustering key. So clustering key automatically gets included in every non-clustered index, which means this non-clustered index that the optimizer is leveraging here, this one and this one here, is actually a full copy of the table. It has all the 5 attributes. Why I was looking into this was because in my query here, we are ordering by quantity. I was trying to see if I can play around with the index, but looks like I can't do much with this index, and I'll tell you why. Let's jump over to the properties window again. My index key columns are product ID and transaction date, and I was thinking if I can actually bring over the quantity from included column and add it to the index key, but this is not going to solve the purpose. Why? Because if I add quantity here after transaction date, which means my index key is going to become even wider, and this will become product ID, transaction date, quantity. It's not going to solve the purpose. Index key is going to become wider. Data is still going to be sorted by product ID, transaction date, and quantity. But I need the data to be pre-sorted by quantity. So the quantity attribute needs to be the first attribute in the index key. If I add quantity as the first attribute in the index key here, then it changes the definition of the index completely. And this might affect all the queries that are dependent on this index and that are dependent on product ID and transaction date to be in this order and first and second column respectively. So that's not going to solve the purpose. But anyway, it's always worth looking into existing set of indexes. This table does not have more indexes. It has this one non-clustered index and one clustered index. That's all. So what do we do? Well, let's go ahead and create another index. But before we create another index, I want you to look into one more thing, right? Pay attention to the usage of star here. Now, do you really need all the attributes? Again, I mean, this is something that I've been covering over in a lot of demos where I talk about query tuning, that it's a bad practice to try and extract all the columns. So your reports, your stored procedures, wherever you're punching in these queries, do you really need to deal with all attributes? Select star in general is not a good thing. So first things first, if this is really how you want to go forward, fair enough, but I might only want, let's say, transaction ID, quantity. This is what I might only need. I'm not going to run this again because this will again fetch data from the same index, and it's again going to use sort operator, and it is again going to spill down. Just changing the attribute here does not make sense. Does not really affect anything. But what it affects is by looking at the attributes that I need in my query, it might alter the decision. It might affect my decision of choosing the right attributes for the new index that I want to create. So what I want to do is, let's say, create index, and let's call it as idx_qty on, and we will use DBO transactions. And our index column here is going to be quantity. Now when I say, now this is interesting, I might only want transaction ID and quantity. So the transaction ID is a clustering key already, so I did not use it again. I did not mention it again in my non-clustered index. I can just say quantity. Let's go ahead and create this index. Now creating this index, of course, might be good and might be the only thing we might need to do, and this is only going to be for this query. Now remember, I'm just trying to show you a a way of how you can get rid of that spilling thing. But it's not a good idea to just go and create one index per query. Never do that. An index should serve as many queries as possible, so to say, in general. But in this particular case, I'm just trying to show you a technique as to how an index or a covering index might be useful. Now remember, this index would not have been useful if you still land up or if you still wanted to use star. Okay, so the index has been created. Now let's go and run this query again. Actual execution plan is turned on. Let's go and execute. Okay, we need to declare the variable. So let's go. Okay, so look at the max quantity. It's still 20. Let's go and execute. Now you only get transaction ID and quantity, and most of you who are watching, you might know what the output probably will be, how the execution plan may look. But those who are probably new to this kind of knowledge, this kind of thing in SQL Server, you will be surprised to see that not only are we getting rid of the spilling, we might also get rid of the sort operator completely, because now the data is pre-sorted, and hopefully the optimizer will use this new index that we created. All right, we're still executing. How much more time? Okay, we are done. Of course, execution goes a little faster now. It takes about 40 seconds. What it took earlier was more than a minute. Because now we have a kind of a better index. Let's jump over to the execution plan, and wow, first things first, single threaded execution, no parallel plan, which means good utilization of resources here. You get rid of the sort operator, and of course, because it was a parallel plan, then you also had those gather streams and distribute streams, etc. So you don't need any of those parallel and exchange operators, because it's just a single threaded execution. And what you expected was the optimizer using your new index IDX underscore quantity. The data is pre-sorted, so SQL Server need not do an in-memory sort again. So it is not sorting. Why would there be spilling also? So you get rid of spilling, you get rid of sorting as well. All right. Hope the content was useful, and sometimes these demos, these learnings, they serve as a good reminder of how you can fix things. Ideally, I would not like to go ahead and create new indexes. I would like to go and look into existing indexes. If one or more indexes could be modified to benefit this particular query. But if there's no solution out there, we might want to go and look into creating a new index. And now you are saving on CPU cycles, you're saving on memory, and you're saving on IO, because when you're spilling down into TempDB, there's a lot of IO going on in reading pages from TempDB and writing back to those pages. Hope the demo was useful and hope you liked the content. Make sure you subscribe to this channel, hit the bell icon so that whenever we are putting up new content, you get a notification. Thank you very much for watching. Happy SQL. If you like the content, give it a thumbs up, subscribe to the channel, and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.